And it's fine, but don't try that at home. So what are we doing here? This is video number 2 of So What Is Electricity? We talk about electricity, but we've got to understand what it actually does and what it is. This is a battery out of a car, and it has got a potential difference of 12 volts. That means there is 12 volts more potential at this terminal here of the battery than there is at this terminal here of the battery. But it doesn't give me an electric shock because it's not pushing very hard. Now, in the last video, we looked at a Graaff generator, a big static electricity generating thing, which had thousands of volts on it. It had thousands of volts. It was full of electrons around the outside, a high pressure of electrons, all trying to leap away from where there's such a high concentration, a high voltage, a high potential, down to where there was a very low potential, where there wasn't any spare electrons, so they could jump across there. And we saw that they jumped actually across the air and made a spark in the air because it was such a large potential difference. But it didn't cause any damage, really. Made my microphone go a bit funny because there wasn't a lot of energy in there. Now, this car battery has got lots and lots of energy in there. It says at the front 56 ampere hours. That means it can provide 56 amps of current, which is massive for an hour. Probably this one, not now, because it's a few years old and it's lost some of its capacity, so it can't hold as much charge as it did before. But this is, so there's lots of energy, but it's not pushing very hard. There's not a big potential difference. Only 12 volts from here to here, which is why I don't get an electric shock, because my electrical resistance is high enough that it can't push the electrons through me with a push of only 12 volts. But if I just had that piece of metal, which I've lost now somewhere, and touched it across there, or if I was just to get these bits and touch across there, you will get big sparks coming off here. Don't try any of this at home, by the way, because you can start fires and things like that and burn people, because this is what welding is. But even though there's only a 12 volt potential difference between this side and this side, the electrons are not at high pressure trying to leap across the air, but if you give them a path, they will take the path, and the easy path is between 2 bits of copper wire like this. They will just start running down there, and if I put those two together, that's going to get really, really hot. So the electrons aren't leaping across the air, but there's just a lot of them sort of ambling their way from one side to the other, so that gets really, really hot because this has got a very low resistance. Now, I've got something here which has got a reasonably high resistance. Let me put this over to the camera so you can see that. This is a bulb from a car, and inside that little ball is a very skinny piece of wire at the top of the 2 little metal prongs. And what happens with that is when the electrons are trying to whiz down from this side to that side and make their way across, all of a sudden they have to squeeze through this tiny little bit of wire, and all the electrons that have been running down these nice fat bits of wire all of a sudden have to squeeze through, and that is a resistance, and it becomes almost like a queue of electrons trying to get through. And the ones that are getting through are bashing against all the atoms and everything in there, and so they make that little skinny piece of wire really, really, really hot so that it glows. So again, this is 12 volts, but we've got quite a good resistance here, and so you don't get lots of current, you don't get many electrons whizzing down there. So that's the difference between a high potential and a high amount of energy. So then we need to measure electricity, and I'm going to measure the flow of electrons from one side of the battery to the other with this thing, and it's called an ammeter. Hope we can see the numbers on there. I'll move that in a second if we can't. And the ammeter, this wire which was going to connect onto my bulb, before it does that, I'm going to pop it in here, so the electricity goes in here and then comes out of here, and then I can light up my bulb again. And on my little screen here, I can hold this right. If I hold that up to the camera, you can see you've got about 0.45, so nearly half an amp of electric current flowing through there. So let's go back to what we were talking about before. Got some words on the board which are really, really important. We spoke about voltage and potential difference. The 2 sides of this battery are at different electrical potentials. This side is at 12 volts and this side is at 0 volts. So there's a difference of 12 in the electrical potential from one side to the other. So it has a potential difference of 12 volts. We measure it with volts, and we use a voltmeter, which looks a little bit like an ammeter, except it says voltmeter on it. And so what I'll do with this is, if I connect that to one side and this to the other side, and I turn that on, that should tell you, what have we got, 12 and a little bit volts. And so you're measuring the difference from one side to another with a voltmeter. And with an ammeter, which measures the current, what you're doing effectively is just counting the electrons that are whizzing down this wire every second. So the ammeter has to be in part of this wire, has to be part of the circuit. So I pop that in there, it goes through there, comes out the other side, into my bulb, and that is the circuit that keeps it going. Right, so what have we got here? So we've got to get used to using these correct terms here. There is a difference in potential between the two sides of the battery, and we measure that in volts. The potential difference is also called the voltage. We measure it in volts with a voltmeter. The electrons move from one side of the battery to the other. Because remember, if you've charged up your battery, if it's got lots of charge, which means you've pushed a lot of electrons to one end, and then they want to get back around to the other end. And so if you give the electrons a route around like a wire from one side to the other, those electrons will flow. And they will flow, and we call that the current. We measure it in amps or amperes, if we're being correct. It was named after a Frenchman called Monsieur Ampère, but we shorten it to amps, and we measure it with an ammeter. And the ammeter is part of the circuit. We say it's in series with the circuit because it has to count all the electrons that go through. So it has to be part of that circuit to do that. We spoke about resistance. The resistance is a measure of how hard it is for electricity to get through something. So I have got a reasonably high resistance. This piece of wire, if I take the bulb out of it, got very low resistance. There's just nothing in the way from one side to the other. So you will get loads and loads and loads. And this wire is hot already because there's so many electrons running from one side to the other. Talk about the power. Power is how quickly the energy is transferred or used. We don't like using the word used, but this is transferring energy an awful lot quicker than if I was to put my light bulb in. So this light bulb here has got a lower power than just the short circuit piece of wire. And the brighter the light bulb, the more power it has, because the more energy it's turning from electrical energy into light energy. And that's it. And the charge is just pushing the electrons from one side of the battery to the other. And then when you give them a chance, you give them a route to go through. That's what they do. They go through. That was lesson 2 on what is electricity. In the next lesson, I think I'm going to show you how to make some electricity and how electricity and magnetism are all joined together. Right. Catch you next time.